Hello and welcome to another Geometry podcast. Today's topics involve angles within circles. Enjoy. An angle whose vertex is on the circle and whose sides are cornered the circle is called an inscribed angle. Okay, inscribed literally means drawn inside or written inside. So an angle inside the circle is called an inscribed angle. And an arc with endpoints on the sides of the inscribed angle and its other point on the interior of an angle is called the intercepted arc. So if you look at this picture right here, angle ABC is an inscribed angle, and the intercepted arc is the arc between the two endpoints, arc AC. All right, now the measure of an inscribed angle is half the measure of its intercepted arc. So angle B is half of the measure of arc AC. Do an example here. The value of A and B. Well, to find A, we're going to use that highlight. That angle right there is the inscribed angle for arc A, for the arc with measure A. So, which means that the angle is half of the arc. So A, 1/2 the arc is equal to 60. Again, the inscribed angle is half of the arc that it cuts. So 60 is half of A, which means that A has to equal 120. For B, angle B is that angle right there. It cuts an arc of 150. So B is half of 150, which is 75. It's half of the arc that it cuts. All right, we need to find angle A, B, C, and D. Measure of angle A is half of the arc that it cuts. So the arc that it cuts goes from B around to D through C, so it's 190, half of 190, which is 95. The measure of angle B is half of the arc that it cuts. Angle B is right there. It cuts an arc of 154. So the angle is 77. The measure of angle C. Well, angle C is that angle right there. It cuts an arc that's equal to 170. So it's half of 170, which is 85. And the last one is angle D. And angle D is half of 206, which is 103. So again, we just take the arc, we cut it in half, and we have the angle. We have the angle, we double it, and we have the arc. Now there's a couple of other theorems to talk about. Some corollaries. If I have two inscribed angles that cut the same arc, then the two inscribed angles are congruent. That's this one on the top left. If an inscribed angle has endpoints on a semicircle or a diameter, then it's a right angle. And if I have an inscribed quadrilateral, then the opposite angles, A and C, or B and D here, are supplementary. E plus D equals 180. Okay? Let's do it an example. Number 3. What's the measure of each numbered angle? Angle 1 is 90 degrees. Now, how did I know that? Well, it's an inscribed angle that intercepts a semicircle. This that arc is a semicircle. It has endpoints on the diameter. For letter B, to find the measure of angle 2, well, this inscribed angle and this inscribed angle both intercept this same arc, so they have to be congruent to each other. So the measure of angle 2 is 38. Now this is a shortcut. If you wanted to, you could have said, well, if this is 38 and this is 76, which means that that is 38. It's half of the 76. You could have done it like that if you wanted to. Theorem 1212 basically says the same thing. If I have a chord and a tangent forming my quote-unquote inscribed angle, it's half, the angle is half the intercepted arc, so it's the same property as what we've just done. So if I look at this question right here, I have a tangent and I have a chord, and I know that arc PMQ is equal to 212. What's the measure of angle PQR? Well, PQR is that angle right there. So in order to find that angle, I have to find arc PQ. Now arc PQ is whatever's left over after I take out the 212 from the entire circle, which is 148. So PQR is half of 148, which is 74 degrees. All right, we're going to do examples 5 through 9 in class, and then work on the practice examples now. Let's turn to section 12.4. In section 12.4, we have angle measures and some more segment lengths. We're going to talk primarily about the angles in the video. If I have two chords intersecting, or two secants, whatever you want to call it, then this interior angle, angle 1, is the sum of is the average of the intercepted arcs. So you take x plus y and you divide by 2. Now, if they intersect on the outside of the circle, like these three do down here, then we subtract the larger arc minus the smaller arc and then divide by 2. So again, if it's inside, if they intersect inside, we add and divide by 2. If they intersect outside, we subtract and divide by 2. For example 1, what's the value of each variable? So to find x, these intersect on the inside, so I add them, and I divide by 2. Now make sure you add the 2 together before you divide by 2, because if you don't plug it into your calculator right, it'll only divide the second part. So I add those up, divide by 2, I get 68. For letter B, because they intersect on the outside of the circle, I'm going to subtract. So it's 95 minus Z all over 2 equals 20. So I multiply both sides by 2. 90, those divide out. 95 minus Z is equal to 40. And now it's just a matter of solving that. Subtract 95. Negative Z equals negative 55. So Z equals 55. 55. Example 2. Now, I could assume that those were both tangents. I don't necessarily want to do that because we aren't 100% sure that those are both tangents. So we'll do this the longer way to make sure we're doing it right. Okay, so I take the large arc minus the smaller arc and divide it by 2, and I get the angle because they are crossing on the outside. I multiply both sides by 2. I get W minus 410 equals 140. W equals 250. Letter B. solving for y. Again, they cross on the outside, so I'm going to subtract them. 110 minus 30 divided by 2. That's 80 divided by 2, or 40 for y. And the last one, I'm solving letter part C for letter X. Now they cross on the inside, so I add the two arcs and divide by 2. So I'm going to solve for x here. I have x plus 30 equals 70, so x is equal to 40. Okay. So those are some basic questions. We will finish up the examples in that packet in class next time, and we'll do the practice problems for that. So I'll see you then.